Hello A-level physics buddies, this is a new episode of Revision with KJ Shreeman. And why am I holding a ruler in this hand? You guessed it by the title, right? To read through the question stem for an A-level physics planning question. This is what I'm going to teach you in this video. The reason why I think this video will help you is if you guys are writing your planning question, you find that either your writing is so messy, not because of your handwriting, but just that, sudden thoughts pop in your mind, like, oh, you forgot something at the start, and then you suddenly need to write it down. It's so messy, right? And not only that, I think some people have time management problems. How do you finish the planning question in 30 minutes? So I believe this video will give you a simple framework, bit by bit, okay? In my future videos, I'll talk about more of the bits. This is the first bit, which is about reading through the questions, okay? And not to leave you guys in suspense. For this episode, I'm just going to dive right into the approach. Okay, so look here. So this is the approach, guys. Identify the topic, precautions, sources of error, independent and independent variables. And this seems a bit voluminous and hard. I'll break it down very simply and exactly what I need to do. So this is the what section. I want to proceed to the how do you do it, right? So to identify the topic, I guess this is the most basic thing. And I don't just emphasize for a planning question, but for a section B question, for chemistry or for biology, for any topic. You need to identify the topic or what's going on. So I'll show you 3 examples right in front of your screen. The first one is about electromagnetic induction. Correct? Because you see a magnet that's dropping into some hoops, so you're talking about the time interval. Or the second one is about superposition. Correct? You're seeing a diffraction grating and all this kind of stuff. Or the third one, which is about some slingshot that's like thrown, I don't know why. And it's about kinematics. So this is something that's very intuitive. You just briefly read and you know it. So identify a topic, why do you want to do that? It's a very interesting question. Why do you want to do that? It gives you a base or foundation, number 1. Okay? The second point is the very important distinction you need to make. Measurable versus inevitable. And here I'm talking about the idea of calculations or the formulas. A lot of you guys are wondering, what am I saying here? Okay, let me introduce what I'm talking about. A measurable variable. In the question, let's talk about a superposition question right in front of your screen. And in the question, they ask you to measure the theta. That's what you write in the procedure, right? You measure the theta. Then you're thinking how do you actually calculate the wavelength of the light? This is a superposition question. I get it. It's a diffraction grating. So we can actually use d sine theta is n lambda. And then you put the theta in, you have the d, then you can calculate out the lambda. So this is the independent variable, but it's not directly measurable, correct? So that's when you will need the topics, because you need the formulas to do this kind of calculations, okay? Now, precautions. Why do you need to take note? Let's look at this. Let's look at a question right in front of your screen. This is a question about some circular motion, right? Some disk is rotating. What is the immediate thing that comes to your mind? Oh, you're placing an object on a disk and the disk is rotating. What if the object flies off and hits somebody and injures someone? You don't want that to happen in the real practical, right? You're planning for some other person to do that exact practical for you, as if, correct? So you don't want these kind of things to happen. Write it down at the side as you read the question stem, the precautions. So the example that I showed you is, what can you do to prevent it from hitting someone? Use some kind of shield. Okay? Another example right in front of you, the slingshot one. You are literally throwing something using the slingshot and it just launches. What if it hits someone? Then what do you do? To prevent injury, you can use a sandbox. Correct? And this is very important when you're shooting or you're dropping some object. Okay, so the shielding example and sandbox, just 2 examples to show you. Take note of these. And why do you want to do that? This is the important part. Why do you want to even take note of precautions? Now, do you know that during your A-level physics practical you need to draw a physics diagram And then during your diagram, right, if you don't take note of this, you will miss it out in the diagram. You need to draw maybe the sandbox or the shielding in the diagram, or you need to explain it in some part of the question. Because if you don't think about it at the start and it suddenly pops in your mind, you're like halfway like, oh shit, I screwed up. I don't want that thing to happen. So you don't want to miss it out on the diagram or some sudden thought comes up. I don't want a sudden thing that screws you up, okay? So that's precautions. Now, sources of error. Now, sources of error. This is a very easy one. So, for example, vernier caliper, micrometer screw gauge. For vernier caliper, how many readings should you take? 2 readings. Correct? And then you take the average. For micrometer screw gauge, it's 3 readings minimum, and then take the average. The reason is why this is important is because you want to, of course, you want to reduce the uncertainty, right? In the reading that you're making, correct? But not only that, you must state it in procedure. This is one of the easiest marks to get. You can just see repeat the reading 3 times and calculate the average detail of the average length, correct? So you must state it in procedure that you are repeating. Okay? So that's the source of error. Now, independent and dependent variables. And this is the main important part because the planning question split 2 ways. Okay? One involves one independent variable. And some examiners try to make the planning part very hard and they say 2 independent variables and 1 dependent variable. So I have 2 examples right in front of you. The first one is the one on superposition. V equals to K lambda n, correct? This is 2 variables, correct? This is the dependent, this is the independent. Now, 2 independent, 1 dependent. Let's look at another example. This is a one on some object rolling down a slope. You got V is equals to C dx hy. So you have 2 independent and 1 dependent variable. So to find the independent and dependent variables, you just need to take note of these and just put it down in your procedure. So all you need to do is just use the formulas. Because the formulas will tell you what variables are independent and dependent, correct? So let me tell you what you need to do after you find the formulas. You need to linearize it, okay? I guess linearization is something that your teachers may have taught you, but I'll just briefly go through what I mean. V equals to K lambda n, you use log or ln. You can use log or ln to linearize it. The main distinction is you must only use ln when there is like an e, an exponent. But you can use log anytime you want. Okay, so for this one, there's no e, right? So if you log v is equals to n log lambda plus log k, correct? For this one, right, it's a bit different. You need to carry out 2 experiments, okay? So this will require 2 experiments. This will require 1 experiment. So technically you have to write 2 procedures, which is a bit more exhausting, correct? So for this one, right, for the first experiment, you keep one of the variable constant. So vary v with h. Okay. Second experiment, you keep the h constant, you vary v with d. So this will be your 2 experiments. So in both cases, you apply the same thing. You make this entire thing, so for the first one, vary v with h, you make this entire thing a constant k and you just apply it over. For the second experiment, you keep chy as the constant, okay? And then you just apply the same thing. It's exactly the same. So that's what I have, guys. This entire photo is in the description, and not only that, it's going to be on my Instagram as well for your reference or if you want to archive it. So please subscribe to my channel. That would be great. I'll be really, really grateful for that. And share with your friends. And I'll see you guys in the next video. Thanks for watching. Bye.